So I've just been discussing operators. Once we master using operators, it's important to start thinking about how we can make use of functions within Python. The same reasoning for functions stands here as it does in any other programming language. The idea is that we write a function for a task that we perform routinely. I just got done with some analysis where I had to do a really complex data manipulation that involved lots of selection of variables based upon matching substrings and things like that. I wrote a function to do it and then applied it about 30 times to the data to accomplish very similar but tasks that required different types of output. So had I not done that, my code would have been, I don't know, 500 lines long. Function, it was just far shorter than that. So make use of functions. It may seem awkward at first to get started, but it really is worth your time to invest in. So again, motivation. Let's say you calculate code or you make some code that calculates a student's course mark. It's a weighted average of like their marks on their lab, their assignments, their exams, and so forth. Would you want to copy and apply it to 3 students, 30 students, 300 students? Then you'd have to copy and paste that same code 3 times or 30 times or 300 times. We're going to have however many students we have, we're going to have that times many more code. And so, and then if there's an error or something, it's going to replicate. We'll have lots of bugs, in other words. Another motivation here. Suppose you're writing a cookbook, has cake recipes, and each cake requires making buttercream frosting. Do you want to explain in every single recipe how to make buttercream? I don't have one cookbook that does that. They'll make reference. They'll say, prepare the buttercream frosting, recipe on page, whatever, and you go back to that recipe. Same thing you do in programs. You define a piece of code once and then you just call it over and over. So just like you might make reference in a recipe to a buttercream frosting recipe, and then you can make reference to where that is in the cookbook, you can make reference to a function and avoid having to recreate it each time. Okay, so when we define a function, this should look familiar. We have to think about the parameters. The syntax is different than what you see in, say, R, but it's a very similar concept. Just get used to the syntactical differences here. So we're going to take a set of functions in this kind of mock function that's been set up. They have arguments A, B, and C. You don't have to have any parameters. Sometimes you don't need parameters. Everything's internal to the function, and that's fine. Then you just have open and closed parenthesis. When we call the function, we have to provide values of any argument we provide. It'll result in an error. If I don't specify a value for A, B, and C, it will result in an error. If you don't have any parameters, then you just call the function with the empty parentheses, just like other programming languages such as R. Okay, so here's an example. If we define the function right now, don't worry about the dot, dot, dot. That's just, we did some things with A, B, and C, okay? Notice how you can pass the parameters and they can use any kind of name for the parameters. So in the function, it's referred to as A, B, and C. I like to make these informative about what their role is. So if they're parameters for some mathematical function, I might name them things such as, well, tau, if like the formula uses the Greek letter tau, or if it's a tuning parameter, or an offset or something like that, I might actually use those words, tuning and offset, for the function parameters here. Then when you're going to call that function, you use assignment operators this is good form, I believe. Here, when f starts running, it's going to assume x, as it's entered in the first place, is going to operate in place of a. Y will operate in place of b. Z will operate in place of c. It's not going to change those values. It's just going to pass whatever's stored in x to be filling the role of a in the function, and so on. Okay, so let's look at a particular function here. We have our function defined, it's called first. We have an argument a. Internally, what happens is we assign 8 to the value of a, and then we return a. Then we can define a to be 20. We can call the function first, and then we can print a. So think about it. What would be the value of, or the output that is printed? Take some time, run this, and then bring it to class so we can discuss. This is worth talking through. Okay, again, what would be the output of the code refined from this set? We'll talk about that in class. Okay, so we have two functions within Python that perform different tasks within a user-defined function. There's the return function and the print. Return is simply a signal to Python that we're terminating the function and we're going to be returning a certain value back to the object or the caller. Okay. If there's no return, then the function's not going to return a value. In fact, it returns the value none, particularly. So I shouldn't say it's not returning a value. It's just not returning a value that's useful. So the print function, though, just prints to the screen. That it's simple enough. So print can take on, one argument or more, and it just prints them out with spaces. If you put print at the end of your function, it will not return that value from your function. You have to use the function return for that. So if you use print, say here, it would return none when I call first. So be careful about not mistaking or conflating return and print here. They really have two different distinct roles. So let's make sure we understand that here. We're defining a function f1. It doesn't take any argument. It just returns a 5. f2, it prints a 5. f3, it returns a print 5. So what of the following would assign a 5 to x? This one, this one, this one, all of them, or just two of them? So I think one of these is pretty obvious that it does return a 5 to the value x, okay? Maybe it's less obvious with the other two. So you can try this out. I really recommend typing, doing this the hard way, remember, typing and trying this out and then thinking through what is happening when we run these codes. Pay attention to the ones where you have some perhaps doubt about the output. Okay, so how do we decide on which parameters we need in a function? I I think this is from a textbook, these rules, and I like them. I don't know that I always very well think this out when I'm writing my own functions. I often will go back midway writing a function and add some parameters because I usually under-parameterize at first and then realize that I haven't written a generalizable enough function. So I go back and add things. And if you work haphazardly like me, maybe that works as well. But this is a really good rule of thumb to think about when you're trying to choose a set of parameters for your function as you write it. So you ask the question, what does the function need to know to do its job? And I would even make that a little broader, like what does it need to know and what is changeable from one call of the function to another. That's usually where I get very um, hung up is I'll put something in and I realize, oh, I can't always assume I'm going to use this value for tau. I might want to change tau from time to time. A style rule. Everything it has to know should be provided as a parameter. That's a good style rule for any programming language. And then this textbook author defined what we call the LGB rule for variable lookup. Functions can access local variables. This includes the parameters, so those things that are internal to the function. The global variables, using global variables in a user-defined function is not good style at all. Or I should not use a negative there. I just say it's bad style, right? You can use built-in variables though. So functions, things like, well, certain values like mathematical constants are not coded in Python as they are in say R. But any built-in variables we can use. So let's apply this now that we've talked about the rules. Okay, so we have a function a. The parameter is num. Then we have a function b. The parameter is val. Then we call b2. What's going to be the output? Again, when we're doing this, these are thinking questions. Really think through how it's going to evaluate this code. Make a prediction, then type it in and run it yourself. Bring your answer to class. I want you to take the time to think through this and not just wait for my answer. Okay, so what changed here? Now we're defining the value 8, or the value of val to be 8. So how does that affect? So two things to think through. Once you understand this one, you're well on the road to understanding this. Okay, so I think that completes it. We have a lot to talk about in class this week, so let's make sure that we have everything run and ready to discuss once we get to class. I think that there's a lot of things to talk through and a lot of issues to make sure we conceptually understand before we move on.